Hello dear friends, welcome to this. In this video, we are going to learn one of the interesting concept of probability which has many real life applications. The name of the theorem is nothing but Bayes theorem. To learn Bayes theorem, there are few pre-requirements that student must know. Let's cover those pre-requirements. The first is nothing but conditional probability, which is denoted by probability of A slash B, and we can read as probability of A given. What is the meaning of this? The meaning of this is you want to find out the probability of event A given that the event B has already occurred. So you are interested in finding out probability of A from the given condition that B has already occurred. To get this probability, we have the following formula. To get the formula of probability of A given B, first of all, we write the numerator as the intersection of these two events. To get probability of A intersection B, in the numerator, you will write probability of A intersection B. And in the denominator, you will write the given event probability. So A given B, that means B is the given event. So in the denominator, you will write the probability of B. Right? So this is nothing but the mathematical formula of conditional probability. One of the confusion that student always have is A given B and B given A same? So I need to clear it. They both are different. If I ask you for probability of B given A, by using the similar concept, we can write the formula. In the numerator, you will write the intersection of these two events. So it is B given A. So it is intersection of B and A, which is same as probability of A intersection B. And divided by the probability of the given event, that is probability of A. So this is nothing but the formula of probability of A given B. From this, one of the important thing that we need to learn is probability of A intersection B can be written as probability of A given B. And if I just multiply this to this side, so I'll get probability of A intersection B is equal to probability of A given B into probability of B. So this is nothing but the important formula which will be required for Bayes theorem. After this, the second condition which is required or to learn is nothing but the partition of a sample space. We say that events E1 to En are partition of the sample space S if it satisfies two conditions. The first condition is this events E1, E2 till En should be pairwise disjoint. They should be pairwise disjoint. That means there is nothing common in between them. So their intersection with any of the other event from E1 to En are going to be empty. The second condition to be satisfied is nothing but if you consider the union of them, E1, E2, union till En, if you consider the union of all of them, you should get the sample spaces. If these two conditions are satisfied, then we say that E1 to En are nothing but the partition of the sample spaces. Right? This is the second pre-requirement for us. And the third and the final thing that students should know is nothing but the theorem of total probability. The theorem of total probability states that if E1, E2, En are partition of the sample space S and A is an any event of S, then the probability of event A is given by the formula. The formula given in the total probability is sigma, the sum of the probability that the event A will occur given that it is with any of the partition event EI multiplied with probability of the partition event EI. And it is for I running from 1 to n. That means to get the probability of A, first you will find out probability of A given that it is event E1 multiplied with event probability of getting event E1, plus you will do the same with E2, probability of A given E2 multiplied with probability of E2, and this will continue till the last event of partition, that is probability of A given En multiplied with probability of En. Right? So this is nothing but a theorem of total probability which is required for Bayes theorem. Now, finally, we can study the statement of Bayes theorem in the proof. The statement of Bayes theorem goes like this. If E1, E2 dot 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 till En are n not empty events which constitute a partition of the sample space S. Now we know what is the meaning of partition. That means they are pairwise disjoint and the union is S. And is any event, then Bayes theorem states that probability of EI given A is given by this formula. And our first task is to prove this formula. To prove this, we require two important notes. The first is probability of A intersection B is equal to probability of A given B into probability of B. And the second is nothing but the theorem of total probability, which we have learned just now. If you know this two results, the proof is very much simple. Let's see the proof of Bayes theorem. Right? And if you understand the proof, you can easily remember the formula, right? Because the formula looks very difficult, but once you understand the proof, every time you can remember the formula by the proof. So to get the proof, first thing is I write the left hand side. The left hand side given is probability of EI given A. By using the formula of conditional probability, I can write it is nothing but intersection. In the numerator, I have to write intersection. So it is A intersection with EI. In the denominator, I have to write the given event. Given event is what? What is a given event? Given event is A. So I'll write the given event, that is probability of A. In the numerator, what I'll write? In the numerator, by using my first note, I'll write it is going to be probability of A given EI. By using the first note, the intersection can be written as probability of A given EI multiplied with probability of EI. Right? And in the denominator, by the theorem of total probability, that is our second note, I can write probability of A is equal to sigma, that is summation of probability of A given EI, but I should use some other index since I is already used. I use J into probability of EJ, where J is running from 1 to N, and which is nothing but the formula that we require. Right? So by using the simple things, we can easily prove Bayes formula. Now, this formula looks somewhat complex, but once we apply into one of the example, it will get more clear. The example that I have considered over here is as follows. There are bag 1 which contains 3 red, 4 black ball, while the bag 2 contains 5 red and 6 black ball. One ball is drawn at random from one of the bag and it is found to be red. Find the probability that it was drawn from bag 2. Now, there is something which is given. They knew whatever ball has been drawn, it is red in the color. So that means the found to be red, that means the given condition is it is a red ball. First thing that I do is I just write all the elementary event use. Let R be the event getting red ball. Let B1 be getting from bag 1. Bag 1 is selected. Bag 1 selected. And then B2 be bag 2 selected. Now from this, after reading the question, I will first write what to find. What is something that I need to find over here? What they want? They want the probability of it is being back 2. So they want the probability of getting back 2. But what event is given? Given that it is a red ball. So they need to find out this probability of B2 given R. And by the Bayes formula, what we have learned, probability of B2 given R. As it is always difficult for student to apply this into an example, I always say go by the proof. What we have done in the proof, first we have used a conditional probability. So it is probability of B2 intersection with R, right? So I'll just write that B2 intersection with R, that means it is R intersection with B2 divided by, what is a given event? It is probability of R, right? The given event is probability of R. Now in the numerator, by using that formula, note 1, we can write it as probability of R given B2 into probability of B2. In the denominator, I have used the total probability theorem, which states that probability of R, I want R, given it is from B1, then I will multiply it with probability of B1 plus probability of R given B2 multiplied with probability of B2. Since the formula is difficult to understand or to remember, then go by the proof. Now in this, I write all the probabilities over here. So the probability of selecting bag 1 is half, because out of 2 ball you will select, out of 2 bag you will select any one of the bags. So probability is 1 by 2. Same goes for bag 2. Now what is probability of getting a red, given that it is from bag 1? Bag 1 has 3 red out of total 7. So it is going to be 3 by 7. Similarly, probability of getting a red ball out of bag 2, given it is from bag 2. So bag 2 has 5 red out of total. Total, if you see 5 plus 6, 11. So it is going to be 5 by 11. I write all of this into this formula, probability of B2 given R. I write all the probability that I know. Probability of getting red, given it is B2, so it is 5 by 11 into half for probability of bag 2 divided by probability of red given B1, so it is 3 by 7 into half plus probability of B R B2, so it is 5 by 11 into half. What I can do is I can just take half common from all of them. So in the numerator I have 5 by 11 divided by half common, so it is 3 by 7 plus 5 by 11, right? And into half in the numerator, if I cancel the half from both the place, I'm left with 5 by 11 divided by, I just cross multiply this, right? I just take the LCM over here. So it is 33 plus 35 and divided by 77. So it is going to be 5 by 11. The denominator, the fraction in the denominator will get reciprocal and multiply. So it is 77 divided by, if I see this, it is going to be 68. Right? And if I just do the cancellation over here, it is going to be 7. So in the numerator, I'll get 35. In the denominator, I'll get 68, which is going to be my final probability. So this is one of the application of Bayes theorem in the problem of bag and ball, right? This is how we apply it. So this Bayes theorem is applied to find out the reverse probability. Usually we always think about getting a red ball from the bag 1, red ball from the bag 2. But Bayes theorem will be helpful to find out the reverse probability. You know it is a red ball, then what is the probability it was from bag 2 or from bag 1? It helps you to answer the reverse probability if they ask for it, right? I hope you understood this Bayes theorem in the example. If so, don't forget to like, share and subscribe to the channel for such more videos. Thank you so much for watching this video till the end. Bye bye.